Good morning, afternoon, or evening, cats and dogs. We've got another math video for you. So this is going to come from your lesson 1.4 guided notes. So please make sure you have those out in front of you as we go through some types of properties, how to use them, and how to apply them to some math situations, but also how to identify them. So the first page of your guided notes really just takes some time to lay out the different properties of math that you need to be familiar with. So I'm going to go ahead and slide this up a little bit here. So the first two properties go hand in hand. They are the commutative properties. This is one that I usually find that students are already familiar with. They've seen it before in their math classes, and they already know how to use it. So the commutative property of addition is our first one here. And the commutative property of addition, you can write either as commutative property of addition. That's a lot to write. Or you can write commutative with a plus sign in parentheses after it. So the first thing I did for each of these properties was I put the symbols, the algebraic symbols that we use to represent each of these properties. So right here I've got A plus B equals B plus A, but that's very abstract and that's difficult to understand. So I also gave examples of each property using numbers. So we've got 4 plus 6 equals 6 plus 4. 5 plus 6 plus 10 equals 5 plus 10 plus 6 using three numbers. And then this last one here, I'm going to highlight this last one because this is the one that is always difficult for students to identify. This also represents the commutative property of addition, and I'm going to mention why in a moment. Let me just delete this box here so we can see what this says. Let's see if that'll delete it for us. The commutative property in our own words, whether it's addition or multiplication, is that you can add or multiply in any order. We kind of notice that from the examples and symbols that are given. The reason why this last statement is the commutative property is because two things switched order, x and y times 2. The operation that's between those two things is addition, which is why it's the commutative property of addition, even though there's also multiplication in that statement. But again, commutative property of addition basically says we can add in any order we want, which makes sense. Back at elementary school, you probably learned that 4 plus 6 is the same as 6 plus 4. Now, we also have the commutative property of multiplication. The symbols are A times B equals B times A. I gave some examples here. I used parentheses for one of these, and the reason why I did, I'm going to highlight this one also. Students tend to mistake this one for the associative property because they think associative property is parentheses. This is not the associative property though, because those parentheses represent multiplication. They're not grouping anything. So the order of the numbers is switching. 4 times 9 equals 9 times 4. So that represents the commutative property. Pretty standard example down below, 5 times 10 equals 10 times 5. And then this last one down here is the one kind of like the third one up here that's a little tricky because you have both addition and multiplication in there. But again, there's two things that are switching order, y and z plus 2. And the operation that's between them is multiplication. So that's why it's commutative property of multiplication. And again, I want to stress the way we write this is commutative with a times sign after it. You can use the dot. You're going to see that I'll sometimes use an X because I'm just typing it in really quickly, but you can also use the dot to represent it. So that's the commutative property. Again, you're probably already familiar with it. Now, up next will be our associative properties of addition or multiplication. Let me go ahead and delete this box so you can jot that down in the meantime. Basically, the associative property says you can move the parentheses to regroup terms in the expression. So this is where we do have parentheses, but we're regrouping things. The order of the numbers or terms is not changing, but where the parentheses are changing. So we have the associative property of addition, which again, we have two ways to write it, a shorter way and a longer way. You probably want to use the shorter way. In symbols for associative property of addition, we have A plus B plus C equals A plus B plus C. Sounds the same, but I moved where the parentheses were. So I regrouped terms, which makes it associative. I'm allowed to do that. It will get me the same answer on both sides of the equal sign. Now this one is different than the commutative property though, because you cannot mix addition and multiplication for this property at all. If you do, it's not going to work. Now, associative property of multiplication, again, we have a shorter way to write that. We have A times B times C equals A times B times C, but where the parentheses are moved. I've got a couple of examples here. Again, you're going to notice the parentheses change from being around 3 times 6 to being around 6 times 11. The same way up here, the parentheses shifted from around 6 plus 2 to around 5 plus 6. Again, the parentheses move their position. So we are regrouping terms in the expression, but leaving the order the same. You will always see parentheses for associative property, but be careful. Don't assume that if you see parentheses, it has to be the associative property. Like this example up here that I highlighted right here, this is commutative property because the order of the numbers changed. So far we've got commutative property, the order changes. Associative property, we move the parentheses to regroup terms. Now, I separated the identity properties. So let's start with the identity property of addition. We also call this the additive identity. So A plus 0 equals 0 plus A equals A. And my examples, 4 plus 0 equals 4, 0 plus 10 equals 10, and 4x plus 0 equals 4x. So what does this mean? It means that when you add 0 to a number, you get that same number back, which makes sense. The way I like to think of identity, your identity is who you are. So if you look in a mirror, you're going to see yourself. So when we talk about the identity property, if you add 0 to a number, you get the same thing back. It's like your reflection. Now, for multiplicative identity, that's a big word, I know. Practice trying to say it at home if you've got some extra time. It's a tough word, but multiplicative identity or identity property of multiplication, again, we have the shorter way to write it, is not multiplying by 0. So if I want to get the same thing I started with, I have to multiply by 1. So A times 1 equals 1 times A equals A. So anytime I multiply a term or a number by 1, I get that same number. So again, to review, commutative property, we switch the order. Associative property, we move the parentheses to regroup terms. The identity properties, we either add 0 or multiply by 1 to get the same thing we started with. My last property, so we've got 3 essentially at this point. I know they're separated into different sections, but our 4th property is the multiplicative property of 0. I've seen some shorthands in books before, like MPOZ. You can even put like multiplicative property with a 0 in parentheses, property of 0 with a multiplication sign after it. But don't just write 0 property, like what operation are we talking about? Be specific. So multiplicative property of 0. I'll tell you though on your test, it's matching, so you don't have to physically write it out, so that helps. So our symbols is A times 0 equals 0 times A equals 0. And then in our examples, you're going to notice that anytime we multiply something by 0, we get 0. So multiplicative property of 0 kind of makes sense. You multiply by 0, and hopefully you know you get 0 when you multiply by 0. So 4 properties: commutative, associative, identity, and multiplicative property of 0. There is no addition property of 0 because that's really the additive identity up here. So you don't have 2 for that. All right, so that's a lot of information on that first page. Let's do some examples of identifying properties. So I'm going to type these in as we go through the examples. We're going to begin with number 1. The directions ask us to name the properties shown by each statement. So taking a look at that statement, we have 75 plus 25 equals 25 plus 75. The order of the numbers changes. So what property is that? It's the commutative property, and the operation we have is addition. So commutative property of addition. Let's look at number 2. We've got 2 times 3 times 4 equals 2 times 3 times 4. All right, the order is the same, but the parentheses moved. What property is that? This happens to be the associative property of multiplication. Make sure that you put the operation that you're using after it as well. On your test, since it's matching, they don't separate it out to the different operations. You won't have to choose the operation, but I still like to be as specific as possible. Again, those parentheses moved, it's associative. Number 3, 14 times 1 equals 14. I multiplied by 1 to get the same thing I started with. What property is that? If you were thinking the identity property of multiplication, you are correct. Remember, you can use the dot or the X for multiplication. Typically, we use the dot. That's more of a pain for me to add in, so I'm just using the X. Number 4, 0 times 9 times C equals 0. Well, we multiplied by 0 to get 0. That's the multiplicative property of 0. I will let you abbreviate property as prop. And if you want to use the number 0 instead of writing out 0, that's fine. Practice writing out multiplicative. It's just like in elementary school when you want to practice new words, you write them out. All right, number 5. 6 plus 5 plus m equals 6 plus 5 plus m. The order didn't change, but what did? The parentheses. So when the parentheses move to regroup terms, this is the associative property of addition. Oops, forgot those parentheses there. I got it. All right. Up next, number 6, I have a star next to it because this is one that tends to trick students. I've got 2 parentheses 6 equals 6 parentheses 2. So pretty frequently, students say this is the associative property because they see parentheses, but the order of the numbers is changing. There's no regrouping of operations or anything like that. Those parentheses represent multiplication. 2 times 6 equals 6 times 2. This makes it the commutative property of multiplication. Number 7, 3r plus 0 equals 3r. We add 0 to get the same thing we started with. That means it's the identity property of addition. It's tempting to say multiplicative property of 0, but we're not multiplying by 0. So think about that. Number 8, we've got 5 plus b plus 8 equals b plus 8 plus 5. So the parentheses remain around the b plus 8, which eliminates the associative property. But the order of the 5 and the b plus 8 changed. And when the order changes, that's going to be the commutative property. And of course, that's going to be the commutative property of addition. All right, number 9 has a star next to it also. So looking at this, we've got 4 times c plus d equals c plus d times 4. The parentheses are still around c plus d. It is not associative. But the order of the 4 and the c plus d is changing. That's commutative. And in this case, it's going to be, let me move that up, the commutative property of what operation? If you were thinking multiplication, you are correct, because the operation between the 4 and the c plus d is multiplication. Finally, in number 10, we have 1b equals b. We're multiplying by 1 to get the same thing we started with. That will be the identity property of multiplication. Try to make sure you write, and again, I know on your test it's going to be matching, but try not to write identify with an F. You know, again, these are just things to be very specific about. All right, I believe next I have some independent practice for you to try on this. This comes from the actual textbooks that go along with this course. We use the guided notes. Go ahead and give these 6 questions a try. Pause the video, jot them down, try them someplace, or at least think through them. All right. Hopefully you paused the video and you tried each of these questions. Number 2, this one should be the commutative property of multiplication. We switch the order around. Number 3, multiply by 1 to get the same number we started with. That's identity of multiplication. Number 4, the order of the 3 and the 9 switch. That's commutative property of addition. Number 5, we add 0 to get the same thing we started with. That's the identity property of addition. Number 6, the order of the numbers change. That's commutative property of addition. And finally, number 7, the parentheses move to regroup terms. That's going to be the associative property of multiplication. All right. let's go ahead and take a look next. I'm going to slide through some extra slides that I have in here from previous years, if I went too far, to some counterexample questions. So I like these problems. They're probably not the most important problems, but I think they're good for us to talk about some terminology here. So it says a counterexample is an example that shows that a statement is not true. We use counterexamples pretty often. You only need one counterexample to prove that a statement is not true. So we're going to have some examples here where we try to figure out if the statement is true, and to prove that it's not true, if it's not true, we can give a counterexample. So number 11, it says, is subtraction of whole numbers associative? Well, I've got to pick some numbers. Since the associative property always involves at least 3 numbers, I chose 3 numbers. I made them all different so we wouldn't get confused. So I chose 12, 9, 5. You could choose different numbers. These just happen to be the ones I chose. So what I'm going to do is I'm going to put them in a statement to see if the associative property applies. So I just put them in order from least or greatest to least from left to right. So I did 12 minus 9 minus 5, put the 9 minus 5 in parentheses. And I wanted to see, really there should be a question mark there, like, is this true? Equals 12 minus 9 in parentheses minus 5. So I want to see, is that true? Like, can I move the parentheses around and get the same solution? So let's calculate out each side and see if the two sides are in fact equal to each other. So the left-hand side, if I do 9 minus 5, I get 4 using those order of operations. So on the left-hand side, I've got 12 minus 4. On the right-hand side, 12 minus 9 is 3, so I've got 3 minus 5. Well, 12 minus 4 is 8. 3 minus 5, we haven't talked about negatives yet, but 3 minus 5 is not 8. It is negative 2. So that statement is not true. That, in fact, is a counterexample. It proves that the subtraction of whole numbers is not associative. Could you perhaps find 3 numbers where it would work? Yeah, maybe. But if it doesn't work for every number, then it is not a true statement. So if we come up with a counterexample, it's not true. So I can state, no, subtraction of whole numbers is not associative. All right, number 12. Is the product of odd numbers always even? Well, I needed to choose 2 odd numbers. So I happen to choose 7 and 9. Again, you can choose, excuse me, any numbers you want. I chose 7 and 9 in this case. So I did the product of 7 times 9 to get 63. 63 is not odd. It is not even. Goodness, Mrs. Garcia, I'm going to fix that right now. 63 is not even. That's what happens when I type stuff up. I make some mistakes every now and then. So 63 is not even. So that means that this statement is not always true. So the product of odd numbers is not always even. In fact, it will not be. Think of other examples. 3 times 3 is 9. That's odd, not even. If we take 11 times 9, we get 99. That's odd, not even. So anytime we multiply 2 odd numbers, we actually get an odd result. All right, so that's counterexamples. Again, probably not the most important part of this lesson, but I still think it's good for us to talk about and look at coming up with counterexamples to prove that something isn't true. When you take geometry, that will probably occur in 9th grade for you. You'll do a lot of this logic kind of stuff. It's actually my least favorite thing, but you do go through it quite often. All right, I'm going to slide ahead. There's some random things from previous years. To numbers 13 through 22. These are the last problems we're going to go through together in this video, so we've got maybe about 8 to 10 minutes left. So it says to simplify algebraic expressions means to write them in a simpler form, usually with variables still in the expression. So this tends to throw people off a lot because they get answers that have variables in them. That's okay. We're in pre-algebra. You're going to get a lot of variables in your answers, and that's all right. So I did 2 examples for you, numbers 13 and 14. The directions, not surprisingly, ask us to simplify each expression. And this is a common question I get from students. They're like, what do you mean by simplify? It's basically do as many operations as you can. Just know that you're probably going to have variables left in your answer, and that's all right. So number 13, we have 24 plus in parentheses x plus 6. So I reordered the x plus 6 using the commutative property, and then I moved the parentheses using the associative property to be around the 24 plus 6. So I don't normally write all this work out, and I won't for all of them. I do this mentally. That's okay if you want to do it mentally as well. But I want to show you why you get a solution of 30 plus x, or x plus 30 because addition is commutative. It's because you can switch the order of the x plus 6, you can move the parentheses to regroup the 24 and the 6 together, and then of course you can add 24 and 6 together to get 30. So the final answer is 30 plus x or x plus 30. Do not, listen to this, do not write 30x. That's 30 times x. 30 plus x is very different, so be careful. All right, number 4. What I did was I used the associative property to move the parentheses around the 3 by 4. So I have 3 times 4, which is 12. Tack on the a at the end. Final solution is 12a. Now I know you're looking at that and you're like, man, she showed a lot of work for that. I don't normally, and I don't expect you to either. But I want you to see where these solutions and answers come from. All right, let's take a look at a few practice problems. So number 15, we have 9 plus in parentheses 12 plus c. So I'm just going to pull this off. I reordered the parentheses using the associative property to put it around 9 plus 12. 9 plus 12 is 21, so my final answer is 21 plus c. Now, if you write c plus 21, that's okay as well. All right, number 16. I definitely don't ever show any work for this, but let me show you what I did. I reordered the d and the 0 to put the 13 next to the 0, the two numbers together. I did 13 times 0 to get 0, and you might want to write your answer as 0d or 0 times d, but guess what? 0 times d is still 0, multiplicative property of 0. All right, number 17. I did show work for this one. Again, I think you could probably do it without. I moved the parentheses around the a times 10. I switched the order of the 10 and the a, and then I regrouped the parentheses so they're around the 6 times 10. 6 times 10, of course, is 60. Final answer, 60a. So for number 18, you can see this box is a lot smaller. I did not show any work. What do you think the answer to this problem will be? If you were thinking 24q, 8 times 3 is 24, tack on the q at the end, you're correct. All right, I'm going to skip for a moment 19 and 20. I'll come back to them in a moment. Let's talk about 21 and 22. So 21, box is small. I didn't show work. What I did was I saw addition. I said, okay, I can add 16 and 9 together, drop off those parentheses. 16 plus 9 is 25. Tack on the plus y. Boom. Final answer, 25 plus y or y plus 25. Number 22. I can add 17 and 0 together to get 17. Final answer is 17 plus n or n plus 17. I would accept either of those answers. All right, so 19 and 20 also have stars next to them because students often miss these two. So number 19, I did show some work. I regrouped the 16 and the 22 using the associative property because those are both numbers. 16 plus 22 is going to get us 38. So I get 38 plus 3x, and that is my final answer. I cannot add 38 and 3x together. They are not like terms. And if you're like, whoa, what are you talking about, Mrs. Garcia? We haven't talked about what like terms are yet. But they're not like terms. We cannot combine them. So leave your answer as 38 plus 3x or 3x plus 38. All right, so number 20. What do you think the answer to this one is? If you're thinking 50 plus 2x or 2x plus 50, you've got it. You cannot combine 50 and 2x because 50 doesn't have an x, 2x does. You leave it as it is. All right, I do want to finish this video with some independent practice for you. So I've got 6 questions for you to try. Pause the video, give these 6 questions a try. All right. Let's see how you did. In number 8, you can add the 9 and the 5 together to get 14 plus y or y plus 14. Hopefully you got that. Number 9, add the 3 and the 8 together to get 11, so we get 11 plus k, or k plus 11. Number 10, add the 15 and the 4 together to get 19 plus s, or s plus 19. Number 11, we've got 12 plus 4 that we can add together to get 16 plus m, or m plus 16. Number 12, 14 times 1 is 14. We get 14d. And finally, number 13, multiply 3 by 11 to get 33. So we get 33z. I do typically, when we're writing products like this, put the number in front of the variable. So more often than not, I'm going to write 14d and 33z instead of z33 or d14. Then it kind of looks like you're playing bingo or something. So I do like to put the number in front of the variable for multiplication. All right, so that's it, at least for now, for lesson 1.4. Fairly short and sweet overall, but hopefully you took some time and you did this independent practice. This is something you want to go back and study, both the simplifying expressions and the properties. There's something that students often forget, and it's because of a lack of study. It's a lack of going back and looking at the guided notes, because both will show up on your unit test. Both are important topics. The properties themselves, you're not going to use them very often in real life. You're not going to walk around saying that's the commutative property. I've already brought it up with my 5-year-old, so I'm not sure he knows the term yet, but that's what happens when you have a math teacher mom. But the simplifying expression stuff, that's going to come over again and again and again. So you want to be familiar with that for sure.
So continuing with our guided notes, again, this is lesson 1.4 for the pre-algebra students and properties of numbers for the Math 7 students. Let's take a look at numbers 23 through 25. In number 23, it says, most people wear both socks and shoes when they go to work. When getting dressed, is putting on socks and putting on shoes a commutative process? Explain. So for something to be a commutative process, it means we have to be able to do it in whatever order. So if we're looking at the situation of putting on socks and putting on shoes, could we do that in whatever order we want? Think about that a little bit. Hopefully you're kind of chuckling to yourself a little bit, because that would be a little goofy to put on your shoes and then put on your socks afterwards. So what I said was, no, it is not a commutative process, because you would not put on your shoes and then put your socks on over top. You might slip around just a little bit. You cannot do this process in any order, and therefore it's not a commutative process, because again, it's a little goofy. All right, let's take a look at number 24. Vicky and Tamara are arguing about what property is shown in the statement 4 times, in parentheses, x plus 8 equals x plus 8 in parentheses times 4. Vicky says that it is the associative property, and Tamara says that it is the commutative property. Who is correct? State the operation that is used in the property. Explain. So let's look at what's different on the left side of the equation to the right side. We notice that on the left-hand side, we start with 4, and then we have the x plus 8. And there's multiplication between it. I'm going to highlight the multiplication in purple, but it's going to kind of look a little funky there. And then on the right-hand side of the equation, we actually have the x plus 8 on the left and the 4 on the right, but we still have that multiplication between them. I don't know why I didn't keep this consistent with my colors. Let me fix that. Sorry about that. So our x plus 8 was green. There we go. We started with that. We then had our multiplication, and then of course we had our 4. So what we noticed is that the 4 and the x plus 8 switch order. That's going to be the commutative property when we're looking at switching the order. Often students think Vicky's correct because they know that the associative property involves parentheses, but remember that not every expression that involves parentheses is going to be the associative property. So what we can say here is that Tamara is correct. It is the commutative property because the 4 and the x plus 8 switched order. Now, to figure out what operation it is, whether it's the commutative property of addition or the commutative property of multiplication, we have to look at the operation that's between the 4 and the x plus 8. And that's the thing that's highlighted in that purplish pinkish color, and that's multiplication. So what we could say here, let me go ahead and delete that box, is that Tamara's correct again. It is the commutative property because the 4 and the x plus 8 switched order. It is the commutative property of multiplication since multiplication is between the 4 and the x plus 8. All right, feel free to pause the video to copy any of that down because we're going to take a look. We're going to move on to number 25, our last question from these notes. Number 25 says, students often get confused between the additive identity and multiplicative identity properties and the multiplicative property of zeros. There's a lot of big words there. What is the difference between these properties? Now, I made a really long, in-depth explanation here. This would obviously take you guys quite a bit of time to jot down in class. And whenever I ask students about this, we often have students explain their thoughts. They may even write out their thoughts. It may not be quite as detailed as this. So what I did was I started by just kind of summarizing each property. So the additive identity property says that when you add 0, you get the same thing that you started with. So you're adding by 0 in this case. The multiplicative identity property says that when you multiply by 1, you get the same thing you started with. Again, you get the same thing you started with, but you're multiplying by 1, not 0. So you're multiplying by 1 in this case. Now, multiplicative property of 0, and keep in mind that word multiplicative, it's a really big word. It just really means multiplication. But the multiplicative property of 0 says that when you multiply by 0, the result is always 0. So for the additive identity property, you add 0. Neither of the other properties are you adding 0 or are you adding anything. For the multiplicative property of 0, you multiply by 0. And for the multiplicative identity property, that one's definitely different because while you're multiplying by 1, not 0. So you really have to have an understanding of the properties. Like multiplicative property of 0 basically means you're multiplying by 0, right? And you know when you multiply by 0, you get 0, I hope. The identity properties, remember your identity is who you are. It's like looking in a mirror and you see yourself reflected back. So if we add a 0, we get the same thing we started with. If we multiply by 1, we get the same thing we started with. But again, keep in mind, for additive identity, we add 0. Multiplicative identity, we multiply not by 0, but by 1. All right, thanks for listening.